Hi friends, in the previous video we discussed about internal rate of return. Here we are going to talk about extended internal rate of return, and we will try to appreciate what is special about extended internal rate of return. The XIRR is used to indicate the return on an investment that has multiple cash flows occurring at irregular intervals. These are two key words in this sentence, irregular intervals. And how we are going to capture these irregular intervals? By storing dates for all the cash flows. While the IRR calculation ignores the timing of the cash flows, the XIRR requires the timing of the cash flows. Please recollect, when we were calculating IRR, we were not talking about any dates. We were considering periods. The first cash flow will be 0, second cash flow will be 1, third cash flow will be 2, so on, so forth. But here, instead of period, we will talk about dates. Okay. Now, this is the formula for calculating XIRR. See here, we used to talk about period, and this has been replaced by this. And what is going on over here, we will discuss when we will come to it. But let us see our data set first. This is all about cash flows, and these are dates pertaining to each and every cash flow. See, 1st January 2018 is the date on which first cash flow happened. 10th January 2019 is the date pertaining to first cash inflow. And this date is for second cash inflow, and this date is for third cash inflow, that is 1100. It could be rupees or dollars, whatever. Now, days elapsed. This is the variable which is going to contain 4 elements. Now, what exactly we are doing in this list comprehension? Look, we are doing something like this. We are saying consider dates, that is first date minus, okay, this is second date and this is first date. So what we are going? 374. Okay. Okay. Next, we will say what is the number of days that have elapsed since the first investment, so far as our this date is concerned, right? Second cash inflow. And then we will say this, and we will write 3 here. Okay. See here, 374, 668, 1110. Let us also write this to maintain the consistency. Of course, it will be 0, but still we can write 0 minus 0. This is only to maintain the consistency. So 0, look, how many days have elapsed since this investment from the very first investment? Same, right? 0 days. It's 0. It is 0. Correct? Now, this is precisely what we are doing here. We are reading these dates one by one and each date minus first date, right? And then we will have our days elapsed populated. Okay, let me remove this. Okay, first we'll see and just see. So 0, 374, 668, 1110. This is what is happening here. And we are using list comprehension. Okay, let me remove this. So why we are calculating this? Look, here formula says that please calculate the number of days. When we write, right, this minus this, we'll get 0, then 374, 668, and 1110 divided by 365. Okay, we will come to this. Now, we have three variables: cash flows, dates, and days elapsed. We will create a data frame using these variables. So, this is our data frame having three columns. Correct? Okay. Now, next what? We are going to use XIRR method from PyXIRR module, which we have already imported. Okay, so we will use it and let this method give us XIRR, that is extended internal rate of return. So when we run this, we get 0.2109, means 21.09%. What does this mean? This means that if we consider 21.09% for these cash flows, our net present value will be 0. In other words, if we consider XIRR, that is this discount rate 21.09 percentage, our cash flows will be equivalent to cash inflows. Okay, so that is precisely what we try to find out when we calculate IRR or XIRR. Okay, now we have used this method. Let us use another way of calculating this XIRR. Here we have written this method. This is written by us. And what we are doing here, we are using Newton method, which we used earlier as well while calculating IRR, that is internal rate of return. See, we have imported this method, Newton method, from SciPy module. What we will do is, having written this method, this Newton method is going to call this method. So there are two parameters which are being passed while invoking this Newton method. First is this function, and the second is some initial percentage. And what happens? It invokes this, okay? This rate 0.02, it takes and calculates this and it gets some NPV. Of course, it will not be 0. So again, it will try, again, it will try. It will keep invoking this function. This Newton method is going to invoke this get XIRR method function iteratively. Once it gets NPV 0 or almost 0, it will get out of the loop and it will just not perform anymore. And what it is going to give us? It is going to give us that discount rate, that rate which is making NPV 0. Let us run this and see how it is working. Again, see, same result. So Newton method has already done its job and done it very smartly. It has gone through iterative process to give us this result. See, here we calculated using XIRR method and here we are using Newton method. The result is almost same, 21.09%. Okay. Now what we will do is, we will calculate the same thing using Excel sheet. Okay, now let us use this Excel sheet to calculate XIRR. So we have a function called XIRR here, and we have to give values, that is first parameter, and then second is dates. Having given these two inputs, we will get our result. Again, it is also giving us the same result, 21.09%, right? Okay, now we are back to Jupyter Notebook. Now what we will do is, having calculated using XIRR method, then we also use Newton method. We saw how it works in Excel sheet. Now, what if we don't want to use XIRR method, we don't want to use Newton method, and we don't want to use Excel sheet as well, but we want to calculate using our own piece of code? Then what we will do? See, what we can do is, we will create a list where we will store discount. We will have another list where we will store all NPVs, and we will get into an iterative process. So this is the loop. We are starting from 10% and we will go till less than 30%. And we will keep incrementing every time this percentage by 0.00001%. So we will have several iterations in this piece of program, and then we are the same thing, right? We have put here. And what is this? This is the list comprehension which calculates NPV. Now let us see, compare with this particular formula. So what is happening? Cash flow divided by 1 plus rate. Initially it will be 10%, and then this is number of days, right? So what are these? What number of days means this particular thing. 0. First it will be 0 divided by 365. That will be 374 divided by 365. Then it will be 668, and then it will be 1110. So what happens is, once this comes, our calculation will be done accordingly. So that is precisely what we are doing here. We are reading days elapsed and cash flow. So days elapsed is nothing but days elapsed comes here. This variable name is days. 0 divided by 365, and then what? 374 divided by 365, then 668 divided by 365, and 1110 divided by 365, right? So this is the exponent portion, and then it will happen. So this is what is happening in this particular line, and then whatever rate has been considered, initially it is 10%, we will store in this discount list. And this, after considering 10%, whatever NPV comes, that we will store in NPV list. So this iteration will keep happening. A point comes when our NPV value will be less than 0.001. At that point in time, we will come out of that loop, and we will see at that point in time, right, what was our discount, because we have to consider discount, and we are trying to find out that magical discount rate which is going to make our NPV 0. If not 0, at least almost 0, right? So let us run this and just see here what we are writing. Last two elements of the discount list, last two elements of the NPV list. So let us run this. What is this? This is discount last two, right? Starting from -1. So see, this is last. This is last rate and this is last value. See, what is last value? Last value is already less than 0.001, but it has gone to negative value. We want at least 0 or slightly more than 0. So that will be last but 1. So this is last but 1, right? This is the discount. This is the discount and the corresponding NPV. It is almost 0. So see, again, the calculation is taking place. We are getting almost 21.09%, exactly like this. We got it, right? The job done. So what we will consider? We will consider this stuff, discount list. You'll say 2 give us, and discount NPV list -2. Correct? This one and this one. Job done. We already got our XIRR through our piece of code. Correct? So this is the discount. So we have also arrived at the discount here. Correct? Now what we will do is we have already populated discount list and NPV list. We will create a data frame for that. So discount list, NPV list, we are calling it discount and NP. We are just creating one data frame and we are giving it name as df underscore XIRR. Okay. So this is the data frame. It has got 11,100 rows and of course 2 columns. We will use this data frame to draw this graph. So what it is doing? Exactly the way we did in IRR. See, what is our initial NPV? 402, 10%. Gradually it is coming down and discount rate is gradually going up. And eventually it is coming to negative value and last discount rate is 0.2109. Good. But we don't want this. We will consider this. We don't want to go to negative value. We will go to the value which is maybe slightly more than 0 if we are not getting 0. So this is the discount rate and this is the NP value, and we are considering this NP value to be almost 0. This one, correct? So this is the graph. So let us read that. Look, this is our 0, right? This is net present value. This is 0. This black horizontal line. And what is this red? This is somewhere 21.98. This, that is 0.21098 here. And it is intersecting this, right? Where it is intersecting. And look at the blue. This is coming right from 402 till this particular point. It will keep coming down, 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 down. And the point where it is intersecting, that is precisely what is our NPV value. We cannot highlight this because we don't have such precise scaling. So here is our the desired NPV, almost 0, right? It is intersecting. See, it's coming right from here and it is touching our black horizontal line. And this vertical red line is nothing but our XIRR, that magical number which if you use for all our cash flows, our NPV will be 0. That means our cash outflows will be equivalent to our cash inflows. Correct? Now, if we want to see If you want to zoom in this particular graph, we are using all the data in this particular list, right? 11,100. What we can do is we will see only last 50 records or last 50 values. And hence, so you see from where it is starting? It is starting from 1.4. What is that? Let us see that last 50, right? So, okay, it has scaled it accordingly, and the same graph. But what we are doing over here, we are considering only last 50 elements, and then again it is coming down and it is merging over here. This is nothing. So this is the graph actually. We are considering all the elements, and here we are considering only last 50 element. That is the difference. So this is all about XIRR. We can write many more programs or piece of code, and we can consider little more complex cash flows, and we can calculate XIRR. That can be done in next video. For now, that's all. Thanks for watching, and I will see you in the next video.